All right, today we're diving deep into one of the most foundational and, honestly, one of the most debated patterns from that classic Gang of Four book on design patterns, the Singleton.
So let's just jump right in with a question that, every developer runs into eventually. You've got this super critical component in your system, and you need to make sure, guarantee, that across the entire application, there's only ever one of it. So how do you do that? How do you enforce that rule? Because to really appreciate why the solution is so clever, we first have to get a feel for the problem it's solving. Let's call it the problem of many, or maybe too many cooks in the kitchen. The book gives us some really perfect examples here. Think about a printer spooler. Yeah, you could have a bunch of documents all lined up, but you only want one central manager handling all those print jobs, right? It's the same idea for a file system, or for that one single object that holds all of your app's configuration settings. You absolutely need a single source of truth.
And this is what happens when you don't have that. It's just chaos. If any old part of your code can just spin up a new configuration manager whenever it feels like it, you get a disaster. You end up with conflicting settings, you're wasting memory creating objects you don't need, and the whole system just can't agree with itself on what its current state is. It's basically digital schizophrenia.
So what's the first thing we all think of? Oh, I'll just use a global variable. It's easy, it's accessible from everywhere, problem solved, right? Well, no. As the book points out, this is a total trap. A global variable makes an object accessible, for sure, but it does absolutely nothing to stop other parts of your code from just ignoring it and creating their own separate instances anyway.
And this is what brings us to the really elegant solution that was proposed decades ago. A pattern designed specifically to enforce that rule of one.
And here it is. This is the official mission statement, straight from the source. It's a beautifully simple two-part job. Part 1, make sure only one instance can ever be created. And Part 2, give everyone a single, well-known spot to go and get it. And this is the key idea, this fundamental shift in who's responsible. Instead of other classes creating the object whenever they want, the class itself takes total control over its own existence. It becomes the sole guardian of its one and only instance, and its job is to protect that instance from ever being duplicated.
Okay, so let's pop the hood and look at the blueprint. How does a class actually pull off this ultimate level of self-control?
Here it is, the official diagram right from the book. Now, it looks pretty simple, but don't let that fool you. Every single piece of this diagram is playing a critical role in making sure that rule of one is enforced. Let's break it down.
This is the magic trio, the three pillars that hold the whole pattern up. First, you make the constructor private. Boom. Just like that, with one simple keyword, you've made it impossible for anyone outside the class to just use the new operator. Second, inside the class, you create a private static variable that's going to hold the one true instance. And third, you create a public static method, usually called getInstance or something similar, that is the only door everyone has to go through to get access.
And this shows you exactly how it works in practice. A client never says new Singleton. They can't. Instead, they have to go ask the class itself, hey, Singleton class, can I have your instance? The class then looks and says, do I already have one? If it doesn't, it creates it right then and there. If it does, it just hands back the one that already exists. It is the ultimate gatekeeper.
So, theory is great, but the real world is messy. It's got complications. So let's look at how this actually gets implemented in code, and more importantly, where a huge modern-day pitfall is hiding.
So this C++ code from the book shows a really common and efficient way to do it, called lazy initialization. See that check right there? The if_instance equals 0? The object isn't actually created when your program starts up. It's only created the very first time someone calls that instance method. And that's pretty smart, right? Because if you never actually need the object during a particular run, you never have to pay the cost of creating it.
But that lazy approach opens up a really critical question, especially for all the multi-threaded apps we build today. What happens if two different threads in your program try to call that instance get method at the exact same microsecond?
Well, you get a classic race condition. It's a huge problem. Picture this. Thread A looks and sees the instance is null. But before it can do anything, thread B also looks and sees that the instance is null. So now, both of them go into that if block, both of them create a new object, and bam, your Singleton isn't single anymore. The core promise is broken. The fix is to make that whole creation block thread-safe. The simplest way is to use a lock, or a synchronized block, which basically ensures only one thread can be in that critical check and create section at a time. Now, there are more advanced, higher performance ways to do it, but they all solve this same fundamental race to create the object. So now we get to the heart of the great debate. Why is a pattern that's so clever also so controversial? Well, it turns out the very features that make the singleton so powerful are also the exact source of all the modern criticism against it.
So on the one hand, you have the benefits listed in the book, and they're clear. You get controlled access, it's way cleaner than a plain old global variable, and it's more flexible than a static class because you can do things like subclassing. But look at the other side. Those same exact features are now often seen as huge problems. That global point of access is really just a fancy name for global state, which can make systems really hard to reason about. It also hides dependencies. Some class might be using a singleton deep inside one of its methods, and you'd have no idea just by looking at its public API. And that leads to the biggest complaint of all. It makes unit testing an absolute nightmare. You can't just easily swap in a fake or a mock version of the singleton for a test because your code is hardwired directly to the real thing.
So the takeaway here isn't that singleton is bad or evil, it's that it's a really powerful tool. Kind of like a chainsaw. You know, in the right hands, for the right job, it's perfect. But in the wrong hands, it just makes a huge mess.
So when should you actually reach for it? Well, the book's original advice is still spot on. Use it when you are absolutely 100% positive there must be only one instance. Things like a central system-wide logger, a single place to get all your configuration settings, or a class that directly manages a unique piece of hardware. These are the classic, totally legit use cases where the problem itself demands a single object.
It's also really important to remember that, software design has evolved. For a lot of problems where singleton used to be the go-to answer, we now have more modern approaches like dependency injection that are just better. Instead of a class reaching out to a global singleton, that dependency gets injected into it, usually when it's created. This makes your dependencies obvious, not hidden, and it makes testing way, way easier.
Okay, so let's boil it all down. The singleton's entire job is to guarantee one instance and give everybody a global front door to get to it. It's a classic, it's a powerful pattern, and it solves a very real problem. But you have to remember that with that power comes some very real risks, like tight coupling and testing headaches that you have to understand and respect.
And I'll just leave you with this one last crucial question to ask yourself. Before you go and implement a singleton, really challenge your assumptions. Is this object truly singular by its very nature, or are you just reaching for it because it feels convenient? Because once you enforce that rule of one across your entire system, it can be very difficult to change your mind later on. So, think carefully.